Hi, in today's video, we're starting section 4.3. We already discussed the unit circle, how to memorize it, how to find different trig functions of remarkable angles from the unit circle. Today, we have an example and a problem like the one given in example 1. It says, let theta be an acute angle in a standard position whose terminal side contains the point 5, 3, and we need to find all 6 trig functions. So it looks like theta is not a remarkable angle in the triangle or in the circle, in the unit circle. It's not a 30 degree, it's not a 45 degree, it's not a remarkable one. So how do we do this? First of all, we need to understand that shape. This is a bow shape that you need to memorize. I would call it like a mini mouse bow. So the quadrants are quadrant 1, quadrant 2, quadrant 3, quadrant 4. And those are different positions of theta in different quadrants. So the first step I need to do is I need to decide which quadrant. And this decision is made of the points. So I have the point, which is 5, 3, and it says terminal side. This is where the angle theta starts. And if you're drawing the angle, this is where it ends. So that's what we call terminal side. So we have a point P on the terminal side, and that point has a 5, 3 coordinates. Second, we want to draw the triangle. So once I know which quadrant it's in, I can draw that position. So I will know this is quadrant 1. This is theta, this is the 90-degree angle, and I have to label it. This is the hypotenuse side facing the 90-degree across from the 90-degree. This is theta, so this is the adjacent side and this is the opposite. If you picture this in the xy plane, when I say P has the coordinates of 5, 3, and I'll change the color, this what would be the x coordinate, and this what would be the y coordinate, which is 3. So I will label the 5 3, which means in this case, x is the adjacent and y is the opposite. Now, one more thing we need to know. In each quadrant, we know quadrant 1, x and y's are positives. In quadrant 3, both x and y are negatives. In quadrant 2, x is negative, y is positive. In quadrant 4, x is positive, y is negative. So if I want to go back and instead of using x and y, I'll use adjacent and opposite. Both adjacent and opposite are positive. Both adjacent and opposite are negative. Adjacent is negative. Opposite is positive. Adjacent is positive. Opposite is negative. You're going to see how is that going to help us in finding the trig functions. After drawing the triangle and labeling it, here comes step 3, which is finding the hypotenuse. And one thing about the hypotenuse that you need to know is that the hypotenuse is always positive. And there is a reason for that. We find the hypotenuse using the Pythagorean theorem. So we are always squaring the legs, which in this case are x and y. So I don't care if x and y are positives or negative, I'm squaring them. So even if x is negative or y is negative, the hypotenuse is always positive. So in this case, I'm going to do 3 squared or 5 squared plus 3 squared, which will give us 25 plus 9, 34. and the hypotenuse will be square root of 34. And I'm going to place this on the triangle. And now, as a fourth step, it will be very easy to find the 6 trig functions. Remember, your answer is always or has to be rationalized. So I'm going to write them to the side. The sine of theta is going to be opposite over hypotenuse, so 3 over square root of 34. We'll rationalize it in a minute. I would do the cosecant right away, where I would flip this before I even rationalize it. The cosine is going to be adjacent, which is the x value over the hypotenuse. And I'll do the secant right away. And we will do tan, which is opposite over adjacent, so 3 over 5. And the cotan, we will just flip this. And I'll go back, and anything that needs to be rationalized could be rationalized. And this will be square root of 34 over 3. 3 square root of 34 over 34. And this, I don't need to rationalize it. If I multiply, this would be 5 square root of 34 over 34. And that's all what's needed to rationalize. Now, one thing, because you're going to be working on homework problems, page 347, number 7 through 12. And you are given in some of the cases points that look like that. And those points have something special, different than the one we did. Their coordinates have common factor. So what we need to do before we attempt the problem and follow all those steps, we need to divide by that common factor. So I'm dividing by 2, I'm dividing by 22 here, and I'm working with those simplified ones. And there is a reason for that. If I take that same triangle that I'm working with, and this is P, which is on the terminal side, I can enlarge this triangle, and you guys learned about that in geometry. And those will be similar triangles. I can make an enlargement and multiply by 2 and get another P, but I will still have the same ratio. So the ratio won't change, which is the sine, cosine, tan, all the 6 trig functions won't change whether it's I take the green triangle or that dark pink triangle, because of the ratio, because those triangles are similar. So why working with bigger numbers? We just can simplify and work with the smaller triangle. So go ahead and work on example 2 given in class. Then work on homework, page 347, 7 through